Hi guys, this is Emily again, and today we're going to be going over the power rule. The power rule is a method for taking derivatives for polynomials and radical functions. Okay, so let's just go over the formula for the power rule. So basically, if you have x to a power, let's just say n, then the derivative of that is going to be n times x to the n minus 1 power. Okay, so basically you're taking that power, you're multiplying that in front of the x, and then you're going to subtract 1 to get a new exponent. Okay, so basically let's just go over quickly what that would look like with actual numbers. So if we have f of x equal to x to the third power, then the derivative of that is going to be 3x squared, because we brought that 3 down in front of the x and multiplied it by the x, and then subtracted 1 from the exponent to get a 2. Okay, so it's pretty simple. And you can do this, and you would do this for every single term in your function, and we'll get into that more later when we do an example. Okay, so let's go over what this would look like with a constant for the power rule. So basically, a constant is any term that does not include a written variable. Even though the variable is not written, the constant is still multiplied by x to the 0 power, okay? So it's important to remember that x to the 0 power, or anything to the 0 power, is equal to 1. Therefore, any constant multiplied by x to the 0 is just a constant. And the reason why it's called a constant is because it doesn't change depending on the variable that is plugged into the equation. Okay, so just for an example, if we have f of x is equal to pi to the 4th power, which is just some number, a very large number that I just randomly chose, and we were to figure out the derivative for this, we would first want to rewrite this as pi to the 4th is equal to pi to the 4th times x to the 0 power. And therefore, if we apply the power rule, we bring that 0 down and multiply it out front, and then subtract 1 from the exponent to get an x to the negative 1. So since 0 is being multiplied by everything, anything multiplied by 0 is 0. Therefore, the derivative is going to be equal to 0. Okay, so to shortcut this, you can just memorize that the derivative of any constant is 0. But if you forget that, then you can always go back to using the power rule, okay? So the derivative of e would be 0, the derivative of 1 is 0, the derivative of 105 is 0, etc. Okay, so that's an important note that you need to know. Okay, so let me just kind of explain why is it 0 by using a graph. Okay, so this for this example, the graph of y equals 0 is here pictured. And you can see that the slope of this horizontal line is 0. Therefore, every single point on that line has a slope of 0, right? Therefore, the derivative, which is the slope of the tangent line, is also 0 at every point. So no matter what the x value is, the derivative is going to be 0 for a constant function. Okay, I hope that makes sense. Now let's just go through an example actually using the power rule. Okay, so for this equation, we have f of x is equal to negative 8 times the square root of x plus 9 divided by x to the 7th power. And we want to know what f prime of x is. Okay, so the first step here is to just rewrite the equation, because as it's written, it's pretty hard to use the power rule, right? So we want to rewrite the exponents so that all terms are in the numerator, so that we're not dividing by anything. And we want to rewrite these radicals as exponents. So if we do that, we are going to change the square root into a 1/2 power. And we're going to bring that x to the 7th power up to the numerator by making the exponent negative, okay? And then now you just take the derivative as normal. So basically, we're going to multiply that negative 8 by 1/2 and then subtract 1 to get negative 1/2. And then we're going to multiply by negative 7 out in front of the second term and then subtract 1 to get negative 8. Okay, so basically you take each term individually, and at each term you apply the power rule. Okay, so this is what it would look like after doing that. And then you want to simplify, and if needed, rewrite without fractional or negative exponents. So if we go ahead and simplify that, we have negative 8 times 1/2, which is negative 4. And then rewriting the square root as dividing by square, because it's a negative 1/2, so it's going to be now in the denominator. This 9 times the negative 7 is going to be negative 63. And then this negative 8 is now going to be in the denominator as a positive 8. Okay, and then that's the final answer for that question. Okay, Lastly, I want to go over what a horizontal tangent line is, because these are pretty important in calculus. So a horizontal tangent line is where we have the slope of the tangent line equal to 0. That should make sense. And this particular example has two x values where that occurs, here at x equals -1 and here at x equals 3. Okay, so we can see that the slope here is 0, right? So we are positively increasing here, it reaches 0 and then switches to negative, right? So here we have this derivative equal to 0. This is called a maximum here. And here we also have the derivative equal to 0. This is called a minimum. Okay, so it's important to be able to identify these on graphs. Lastly, I want to go over an example mathematically with how to find horizontal tangent lines. So this question is asking us to find the two x values on the curve f of x equals 2x cubed plus 9x squared minus 108x plus 12, where the function has a horizontal tangent line. Okay, so we automatically know there's going to be two horizontal tangent lines because it tells us that. But if we didn't know that, then I will go into that later in explanation. Okay, so the first step here is to just take the derivative, right? Because how are we going to know where horizontal tangent lines are without first taking the derivative? Because horizontal tangent lines occur where the derivative is equal to 0, right? So let's first do that. And of course, we're going to be using the power rule here. So we multiplied by 3 out here front, subtracted 1. In the second term, we multiplied by 2 and then subtracted 1. And then, of course, our here, we multiplied by 1 because this x has a 1 here. So you're multiplying by 1. And then subtracting 1, you get 0. So x to the 0 is 1. And then, of course, the constant is 0. Okay, so this is our derivative of our function. So let me get into how we know there's going to be two x values. So we know there's going to be two x values here because we have a quadratic function here, right? So quadratics are going to give two x-intercepts when we set this equal to 0. And those are going to be our two horizontal tangent lines, okay? So next we're going to set the derivative equal to 0 and actually solve it. So this is what it looks like if we do that. And then in order to solve this for x, you can do it multiple ways, but this is the way I did it. I just pulled out an x to make it easier to factor. And then if you actually factor this, you get 6 times x plus 6 times x minus 3. So our two x values are -6 and 3 when you solve those for x. Okay. So I hope that this was helpful. And you guys know a little bit more about how to do the power rule and take derivatives. Bye.